Now that we've talked about synchronized methods, let's talk about the sibling to synchronized methods called synchronized statements. And you'll see that this is yet another mechanism that Java provides to support mutual exclusion. So some of the problems with synchronized methods, we talked about some of the cons, they have several constraints. One problem is they're very coarse-grained. So you can have synchronization at the method level, but as I mentioned before, if the methods are really long, then you're overlocking stuff. And there may be lots of parts within a big method that don't actually have to be locked for the entire duration of the method. And as we also talked about, they synchronize on the implicit lock, which could end up causing some confusion in the reasons we talked about before. Let's take a very concrete look at something that's actually part of the Java class library. This is called the exchanger class. An exchanger is a synchronization point where threads can pair and swap elements within pairs. So it's basically a place you come to kind of exchange things, like think of going to the flea market and you're exchanging stuff or whatnot. So that's what an exchanger is. And there's a couple of different ways to implement exchanger. One way to do this would be to have the entire method, like create slot, be synchronized. But that would be very coarse grained, as we'll see. So here's how this would work. So synchronized, there's a method called create slot. This is going to make a new element or new entry into this data structure. And it's going to lazily create the slot the first time it's accessed. So we come in here, we say create slot, and we give an index. And as you can see here, if this is the first time in, then we're going to go ahead and do something. That's one approach. The problem is it's locking, it's too much locking for its own good. Here's another approach. This is going to get rid of the synchronized method, the synchronized method syntax here in the declaration of create slot. So it won't be a synchronized method. And instead, it's going to synchronize only the part that actually needs to be locked. So as you can see here, we're going to synchronize on this. And if this is the first time in, then we do some stuff. So this code here will not actually be synchronized. So this is a finer grain way of doing things as opposed to a coarse grain way of doing things, right? I mean, imagine, coarse grain and fine grain. Imagine walking on like rocks like this in your bare feet. That would be coarse grain. That would be painful. Walking on, sand or dust, not painful at all. So this is finer grain. What we do here is this part's not in the critical section, so it doesn't have to be locked. That assignment is not in the critical section. That doesn't have to be locked. And we're just locking in this part. So we're locking with the intrinsic lock. And only this part is going to be locked with the intrinsic lock. It's also possible to use synchronization on something other than the intrinsic lock. In fact, as we'll see, that's often a really good idea. So as you can see here, in this case, we were locking on this. In this case, however, we're going to lock on something else. This is basically locking on the intrinsic lock of this private variable called slot, which remember everybody in Java has a lock associated, an intrinsic lock associated with it. So we're going to lock on this private field instead of locking on this. And this is an example of synchronizing on an explicit object, which has a bunch of benefits, not the least of which is now you're no longer synchronizing on this, so you can't have people come along and keep you from making progress by trying to lock you on your this object, because you're not locking on this anymore. Okay, so that's another way of doing things. So what are the pros and cons of synchronized statements? So one nice thing is you can have this private field be used as a synchronizer, so this gets around that weird problem we had before. If you use your exchanger and you try to synchronize on it, that won't keep this thread from doing its thing, because it's not using this, it's using some private internal field. So you don't have any contention for it. It's not visible to be contended with. The downside is that the syntax is a little bit more complicated. The nice thing about putting the synchronized keyword at the method level was it was there once and for all. You could glance at the documentation, you could glance at the code, you knew what it did. Now you've got to kind of look in the method, you have to kind of look in the implementation. It's a little bit more complicated, so this, I would argue, is a little bit harder to understand than that. That's really easy to understand. So that's the main thing. It's more complicated, it's not as visible. Let's talk briefly about an interesting use of this example to demonstrate a pattern called the double check locking pattern. You can read more about that pattern here. That's a pattern that I wrote, again, over 20 years ago. And this is an illustration of how that pattern is applied in many different things, including this Java Exchanger class. So the whole point here is that synchronization is done lazily when the initialization is first performed, right here. So we want to do this check the first time in. And you can see down here, we're going to check to see first, is the slot null? And if so, we're going to create the slot. So that's an example of lazy initialization. Once we do this, then it won't be null anymore. And it turns out that there's no need to synchronize this check, this slot check, because reference reads and writes are atomic. This is a very obscure part of the Java memory model. You have to really dig into the spec to figure this out. But if you read the spec, they say that reads and writes of references. So you can see that slot is a reference to a location in the arena array. So here's arena, it's an array. Array subindex gets you slot, which is a reference, and reads and writes to references are atomic. Go figure. And so we can check it here this time. This is an atomic check. And we only go ahead and create a new slot if it's null. So it'll check on the first time in. And we only synchronize during the initialization phase. Okay, so that was just an illustration that double check locking appears in all kinds of unusual places, including in places that use synchronized statements in Java.